Welcome to Six Sigma Black Belt, Course 1, Module 1, Fundamentals of Lean and Six Sigma. Module 1, Lesson 2, The Origins of Lean and Six Sigma. Lean and Six Sigma, as we know them today, represent the best practices currently known to the field of quality and process improvement. This lesson will explain the origins of Lean and Six Sigma and trace their evolution from the 1700s to today. Until the Industrial Revolution in the 1700s, products were created by skilled tradesmen, and the quality of their work was ensured through a rigid and lengthy process of guild apprenticeships and training. After the Industrial Revolution, inspection was used to decide whether a worker's output was acceptable. But because it was not done in a systematic way, inspection only worked well with low production volumes. As organizations grew, so did the need for more effective operations. In 1795, German mathematician C.F. Gauss identified the normal curve while trying to develop a predictive model for defects. The normal curve is one of the most powerful statistical tools used today and is the foundation for tools like statistical process control. In 1911, Frederick Taylor introduced scientific management, which improved production quality by optimizing the way that tasks were performed and simplifying the jobs so that workers could be trained to perform their specialized sequence of motions in the one best way. In 1913, Henry Ford took the idea of the assembly line and improved upon it by adding moving platforms and a conveyor system. He also recognized that the longer a car remained in production, the more it cost to produce. So he was the first person to use the lean concepts of waste and time reduction to reduce costs. In the early 1900s, Walter Shewhart, an engineer for the Western Electric Company, recognized the impact of variation on product quality and developed statistical process control, or SPC, to monitor process variation and identify when it became excessive and required attention. SPC remains one of the most important and powerful statistical tools used by Six Sigma today. Acceptance sampling systems such as Mill Standard 105 and the Dodge-Romig plan were introduced in the 1940s to provide a statistically sound approach to inspection. These systems and statistical process control played an important role in guaranteeing the quality of ammunition and other critical products used by the U.S. military during World War II. After World War II, quality experts W. Edwards Deming and Joseph Juran were instrumental in helping Japan raise the quality of its manufactured products to world-class performance levels in just a few years by teaching them statistical process control and their methodologies for continuous process improvement. Both Deming and Juran were viewed by Japan as key to their recovery after World War II, and both were awarded the highest of honors by the Japanese government. Later, in the mid-1950s, Japanese engineers and business leaders such as Sakichi Toyota, Kiichiro Toyota, Taiichi Ohno, and Shigeo Shingo built upon the works of people like Deming, Juran, Taylor, and Ford, and began to develop concepts such as waste reduction, Kanban, one-piece flow, single-minute exchange of die or SMED, just-in-time, and Kaizen. The Toyota Production System, or TPS, which was Toyota's approach to creating efficient manufacturing processes, was developed from these concepts and is the basis for what we call lean manufacturing today. Also in the 1950s, Kaoru Ishikawa introduced his theory of company-wide quality that involved everyone from top management to the workforce in quality control. Armand Feigenbaum later became the first person to use the term total quality when he presented at the first International Conference on Quality Control in Tokyo in 1969. Ishikawa and Feigenbaum's ideas built upon the work of Deming and Juran to form the foundation for Total Quality Management, or TQM, which was the most commonly used approach to quality and process improvement in the U.S. through the 1980s and into the 1990s. TQM advocated concepts such as customer focus, employee involvement, continuous process improvement, statistical analysis of data, and the integration of quality management throughout the entire organization. Six Sigma originated at a Motorola television factory in Schaumburg, Illinois in the mid-1980s. A Japanese firm had taken over the factory and made major changes to the production processes that reduced the plant's defect rate to 1/20th of what it had been previously. When Bob Galvin became Motorola's CEO in 1981, he challenged his company to learn from this and achieve a 10-fold improvement in performance over the next 5 years. In 1985, a Motorola engineer named Bill Smith wrote an internal quality paper demonstrating the relationship between a product's performance in the field and the amount of rework that had been done on it during the production process. As a result, Motorola management tasked Bill Smith and a recent hire named Michael Harry with finding practical ways to eliminate defects. Together, Smith and Harry developed their 4-stage problem-solving process of measure, analyze, improve, and control, or MAIC, which would later become the DMAIC model. In 1988, grad student John Krafchick introduced the term lean production in his Sloan Management Review article titled Triumph of the Lean Production System, which he wrote while working for MIT professor James Womack. The term lean was later defined more fully by Womack, Daniel Jones, and Daniel Roos in their book about the Toyota production system called The Machine That Changed the World. Also in 1988, Michael Harry introduced martial arts terminology to Six Sigma to describe the level of skill a person has achieved with the Six Sigma methodology. In 1989, Motorola CEO Bob Galvin tasked Harry with spreading Six Sigma throughout the company, and from then on, Six Sigma was no longer a tool used solely by engineers. News of the tremendous financial savings being obtained by Motorola quickly spread, and other companies soon began to copy Motorola's approach. In 1993, Michael Harry moved to Allied Signal and convinced CEO Lawrence Bossidy to adopt Six Sigma. At Allied Signal, Harry further refined Six Sigma to include a system of leadership and support systems built around the statistical problem-solving tools primarily used up to that point. Shortly afterwards, Jack Welch, then chairman and CEO of General Electric, became interested in Six Sigma after learning about its potential for significant cost savings. Six Sigma was so successful at GE that by October of 1995, GE changed its incentive plan for the entire company so that 60% of bonuses were tied to financials and 40% to Six Sigma results. In addition, Six Sigma training became mandatory for advancement at GE, and by the end of 1998, no one would be considered for a management job without at least a green belt. Over the years, as companies continued to find value in both the Lean and Six Sigma methodologies, these two concepts began to merge into one comprehensive methodology, often referred to today as Lean Six Sigma or sometimes just Lean Sigma. We also continue to see the use of Lean Six Sigma spread beyond manufacturing into healthcare, education, banking, retail, logistics, hospitality, and even the government and military. Lean Six Sigma's tools and methodologies have been perfected by constant use over many decades and are used successfully by countless organizations in all types of industries across the world today. With this, the demand for people who can effectively utilize Six Sigma to improve their organization's performance continues to grow. In the next lesson, we will discuss the benefits of Lean and Six Sigma, which will help explain why Six Sigma continues to be such a widely utilized approach to business performance improvement after over 30 years of continued use and growth throughout the world.